I don't know why I said 170 like that, but
All right, also, I'm gonna go ahead and get started for today. I have some problems here for us to kind of just go through. I'll give you a couple minutes to try them out because these are some things that we need that we just kind of review to remind us about exponents as we go into, as you see here, exponential functions. So I know some of these things we worked with, but there's a few that are a little bit different. So make sure you go through and try them out so we can talk about them. I think I got everyone for attendance. Let me double check that. Now, one thing, I don't know what this means. I guess I'll find out after today, but if you all have an online class and you use Proctorial for exams, make sure that you don't wait to take your exams because they're apparently doing a major update. So make sure you do it as early as possible, that if something happens, it can be addressed. I can tell you now, I don't appreciate, this is the second time they've done a major update in the middle of a semester. So you work with colleges, but you don't plan your stuff properly. That bothers me, but just make sure, know that means there could be an issue that's not your own fault or teacher's fault at this point, okay?
I'm a little stressed. I got not a bad grade, but I need to take that exam to pull my grade up. Did the window close for it? Yeah, last night I was in the middle of the I did the top. But it kept talking about old connection and it would cancel it out.
All right, so I'm gonna go ahead and start going through these now, y'all. So as we have here, we're dealing with exponents. That's the key, first of all. Now, the reason we need to look at exponents because we're gonna be moving into what we're gonna call exponential functions. This is one area where we have to distinguish though, because remember, polynomial functions has exponents, but polynomial functions follow that x to the n, where n is an integer like x squared, x cubed, and so on. What we're going to see is we're going to change it to something to the x power as an exponent. So the variable itself is the exponent. That's what we're going to see the change here. So that's why we want to make sure to review some of these. So what did we put for 3 squared? And we're all good with that, meaning 3 times 3 though, from just what that is. Negative 2 squared, what did we put? All right. Now remember, negatives definitely be careful with because that's doubled negative at that point, right? Negative 2 times negative 2 is y, it's a positive 4. But be careful because I could give you something that looks like this, right? And we want to make sure to understand that that's 2 squared and then do the subtraction. Okay, so be careful with the order of operations step. Okay, what do we get for 5 cubed? 125. Are we all comfortable with our calculators in doing this? Is there anything that help with someone here? The calculator is definitely gonna be helpful, right? Some of these, yeah, let's be able to do them, but a calculator, hey, if we can use my calculator, we should be better. Okay. What about 7 to the negative 2? What in the world does that mean? But now the negative is on the exponent itself. Anybody put in their calculator? What do you get when you do that in your calculator, y'all? You get a decimal, right? Well, let's look at it this way. What is 7 squared? 49, right? Why would it give us a decimal instead of 49? What does the negative do? That would be the question. Try changing the decimal to a fraction. And let's see what happens. Because remember, just because a decimal doesn't mean it's not rational. 1/49th, right? So it was still 49, right? But instead of being 49, it's the reciprocal, right? So understand that that negative exponent is the reciprocal. Now, with that said, that with negative exponents, just remember that, hey, anytime I see a negative exponent, I need to flip my fraction or make a fraction. Okay, that's gonna be the nice part about it. I have a couple here that stretch it a little bit, but understand that that's our focus, okay? Now, as far as moving forward with this, what was the property we used with letter E? How do we handle simplifying something like x to the 5th over x cubed? What do you mean? Subtract what? The exponents, right? And that's called the quotient rule. But if you ever get stuck, just remember that means we had 5 x's on the top being multiplied together, right? With 3 x's being multiplied together on the bottom. So like instead of crossing out, that's where subtraction comes in, right? Because each of those would be a factor of 1. Excuse me, any number divided by itself is 1, right? So that's a nice thing about this. So what you'll see there, hey, let's just subtract. So we all good with x squared here? Now, the next one, we're not going to see this all the time now, y'all. I'm just making sure to go over some rules so that if it comes up, we see where it's coming from. But I have 2 things here to deal with again, right? For f, I have the 2y over x, so I have a fraction on the inside and then the negative exponent on the outside. What I want you to see here, though, is that, hey, the first thing you can do here is just go ahead and flip the fraction. You flip the fraction first, the negative is already taken care of, okay? That's the reciprocal operation there. With that said, though, what's being cubed, right, is the entire fraction. So make sure you see here, that means you need to cube every part of that fraction. And one thing I always encourage people, if you ever get stuck and you don't remember, just make up a problem. Like if I made this negative 15, right? Make up a problem that's smaller, like something squared, and just write out what does it look like when I do this and I write it twice. And you'll see, hey, I have 2 x's, I have 2 y's, and then I have 2 times 2. That's a way to kind of help remember when you get stuck, okay? We good though with why the x cubed is in the numerator? The negative exponent is definitely something we want to be careful with because that's going to be something that's coming up as we move forward. All right, is there any concerns with the first 6 that we could talk about before we go to the next 2, which is not, like I said, I don't know if everyone wasn't here, but some of you may have seen this before, but some of you may have not seen this before, so. So you're good with the fact that the y was here and is down here, right? So since it was cubed, I have 3 of them now, right? Where did the 8 come from then? That 2, right? But instead of writing 2 cubed, I just did the operation. Now, so if you need that extra step, that's perfectly fine. Just put it as 2 cubed. What you need to see there, though, is you put the exponent of 3 to every single thing of part of that fraction, okay? That helps? I make sure to put the 8 though, because it's not 6, right? It's not 2 times 3, it's 2 cubed. So that's the big deal. That's like a common error people, they actually not, I don't think it's intentional, right? You're just going fast. Hey, I got my x cube, got my y cube, but then some people write 6 by mistake. So we want to make sure to see, hey, no, it's not. It's 2 cubed, so that's where the 8 comes from, okay? Anything else, though? All right, so what's going on with these 2? Because that's the part that, like I said, you may have seen it before, but I don't know. Not everyone may have seen it before. Yeah, these are going to be rational exponents. And when we deal with rational exponents, you have the power in the numerator. That's everything we just dealt with, right? All those exponents were powers because they were whole number values, integers. The root is the denominator. That's where we're going to see, like we dealt with before, square roots, cube roots, and such, okay? So one of the things that I think is helpful here is rewrite it in the way that you are more familiar with. Like, hey, this is just the square root of 16. And this one would be the cube root of negative 64. Now, you don't have to rewrite it if you remember square root, cube root, because the denominator, it's fine. With the radical notation may help you out if that's something you do recognize. With that said, though, we good if I put 4 and -4? I know we've dealt with radicals in situations like factoring and the equations and functions, but the rational notation, rational exponent is not one we've used a lot. Questions?
It wouldn't be like have imaginary, like
You could still run into imaginaries because of that, but what's going to find here is that we get to choose our domain. So we can, it's kind of like a quadratic. You can avoid it if it just doesn't work. Now, what will happen here is oftentimes the functions we choose to focus on determines that outcome. So understand as we jump into this, we're going to be looking at exponential functions. And my main thing here was it'd be something like, say, 2 to the x. The x is in the exponent itself. That's why we call it exponential. So the basis that we're going to focus on is positive integers. By focusing on positive integers, we can avoid some of the stuff with complex numbers ourselves. Can it come up? Yeah, of course it can come up. You can make that a -2 and figure out what happens, but we're going to avoid that. Is that clear to everyone? Now, with that said, then let's look at what this might look like. So here's a function that we want to find some solutions for and graph it. We haven't graphed this one before, so we have to go back to the basic, right? What were the numbers that we said we should use that, just talking about like a parent function perspective? Because what I would hope you'd see here is like, hey, create a little chart. We're plugging in x values and we're getting out our function values. So what number should I start with? What are some easy numbers to plug in?
Is that a positive
3?
That was a positive 3 on the right. I
I don't know what's going on there, y'all. I must have been talking while doing that. What numbers are nice to work with to plug into a function? Plug in 1, plug in 2, right? Make sure you remember we could also do the negative of those, right? That's the key. Like think of those numbers. Anytime you get stuck graphing though, remember this is kind of the foundation of that, right? Remember that whole idea of parent functions that we're going to be using again here is based on this. With that said, right, some things that we do have to talk about, right? 2 to the -1, 2 to the 0, and 2 to the first, right? Let's just kind of look at the main things because we can build from there, right? 2 to the first is just itself, right? We could just deal with that exponent. So make sure you see here, like this would be 2 and this would be 4. Okay. And you could write it out just like we did in the past with functions if that's where you need to see, but make sure you see that's where I'm coming from. Okay. 2 to the -1, what do we just say that's going to do? Reciprocal, right? Is there a fraction? Not right now. That just means put 1 over what we have, right? So you'll see here, there's not symmetry here, but the nice thing is the value of the negative number, so the 1 when it's -1 or 2 when it's -2, it still gives me the like, hey, 2 to the first, 2 to the second part. The key difference is reciprocal. So instead of 2 and 4, it's 1/2 and 1/4. 1 over whatever you're working with. So that's one thing that's nice about exponentials that, yeah, it can get a little bit more tedious with fractions, but at least those fractions are nicer to work with than others, okay? With that said, then what is 2 to the 0? Really, what is anything to the 0 power? So if I gave you a cubed over a cubed, by subtraction is 0, right? But a number divided by itself is 1, right, as mentioned. Okay, so anything to the 0 power is 1. We're okay with where I'm getting these values from, though? Any concerns here? Now, make sure you go back to the fact that like the base right now is 2, but dealing with exponential functions, that's something that can change. So instead of 2, we could have 3 or 5. We will focus on positive integer values greater than 1. So we don't want to do negative numbers here. We can have fractions. Fractions can happen. We're not going to deal with that though right now. You know, that's not our focus. We're going to focus on certain things. The fractions that I give you though, you can rewrite. So that'll be something, I think I have one of those. Yeah, we'll focus on like, how can I rewrite something to make it something more manageable, okay? With that said though, once I get some points, let's plot them to see what's going on. All right, so with that said, do we see a pattern that we can trace out? Hopefully we're seeing that like from here, I can at least do this. And I added this extra point up here. That would just be if we plug in 3 to show that it's just going to grow what we call exponential, right? It's going to grow faster than anything we've worked with so far. And we're going to call it exponential growth. Now, I didn't go to the other side though. All right. We have to figure out what's going on over here. That's our next step. Okay, but are we okay with my curve so far? All right. Remember, we should expect curves, right? Nice, smooth turns going on. The only thing that we've run into that's different than that so far has been the absolute value. The absolute value is the one that, hey, that gave me a V shape if I have to graph it, okay? With that said, though, I gave this point just to make sure you show it's going to grow like that, and we call it exponential growth. Okay, if you put in 4, all of a sudden now you have not 8, but 16, it just gets a lot faster. What happens if I plug in -3, though? That is something that we want to look at. Right, so it's still cubit, right? But it becomes the 8th. Now, what happens, right? When you compare 1/8 to 1/4, how would you describe that?
Exponentially smaller. Right?
It's smaller, right? Now, with that said, what type of number will we never get?
0.
And I'm glad that we point out 0. That's good because we keep getting closer, but we'll never actually get there, right? If we're only just increasing our distance, like from here to the door, if I say, hey, I'm going to go halfway and then halfway and keep going to halfway, technically speaking, I never get to the door. Now, we know outside of mathematics, I will get there, but from this perspective, I don't ever actually get there. Okay. With that said, though, we'll never get to 0. Well, what's below 0 that if I can't get to 0, I'll never get to those values either. Yeah, I won't ever get to negatives, right? Now, what is that called when my graph starts to look like that? Well, it's still growth because if you read left to right, it's growing. But what did we say when we had this kind of behavior with a rational function? That just because the type of graph I'm working with, it just created this barrier that's there. What were the 2 barriers we talked about with rational functions that can occur? Right. So here we have another kind of naturally occurring. So that we'll see with exponential functions. So understand as we deal with exponential functions, just because it's exponential, right? We're not really going to have any negatives. It will have a horizontal asymptote whenever we look at the graph. Now, as we see here again, this is a parent function. So by default, the horizontal asymptote was always y equals 0. So with any exponential function, you're going to have a horizontal asymptote, okay? And that goes off the fact that, like, as we mentioned, I went from 1/4 to 1/8. If we keep going, it's just going to be 1 over whatever power of 2 we're at. Okay, it never actually gets to 0. Any questions with that, though? Now, one thing I will say, though, and we'll look at it in a second, I can change the base from a 2 to a 3. So instead of having 1, 2, and 4, we'll have 1, 3, and 9. But the same idea is in place, okay? What I want to make sure we're clear here, though, is that first and foremost, we're going to be looking at positive integers greater than 1. That's going to be our particular focus for these. Yes, you can expand beyond that in some cases, but our focus is whole numbers greater than 1. Okay, if I get a fraction, it's typically going to be 1 over something, and we can rewrite it as an integer. Okay. With that said here, we can see something like g of x here, right? And we start dealing with g of x, one important thing that you always want to highlight is going to be like, hey, instead of 2 this time, it has a 7. All right, so some things about 7 that you would want to bring up, because as I've kind of mentioned, is like, hey, 7 to the 0 is 1. So the first is itself, squared is 49, right? Those would be kind of key numbers to help me get a graph going. Not as nice as 2, of course, to have to graph. What are those other things then considered that we see all around it? What was the term we used to describe all of this? Especially if I ask you to graph this. So like it affects my graph, right, in a pretty big way. That's where, as we deal with this, it's its own function, right? We can just start plugging stuff in. Understand, remember, you just plug stuff in, you can get to what you need. But that would be a lot of work, especially because I put that x plus 4 there. Okay. So what you see here is those values are our transformations, right? I highlighted the 7 in green to make sure to show like, hey, these are some things that I would love to work with. It's a lot nicer than 7 to the 5th power. Okay. But those values there then can help me out in many ways. Okay, so remember transformation. So what you're going to find is, though, what I want to make sure to show here is that this is going to be where your horizontal transformations are. Okay, the exponent itself is where we find that. That means then over here, this is going to be our vertical. Okay. There will be some nice things though, but as I mentioned, the next problem, I'll make sure we go over some of that we can highlight. So like as we go over here, my base is all of a sudden 1/3, which as I mentioned, that's not going to be our focus for a lot of the stuff we work with. Okay. We prefer when we have the integer bases, that definitely makes it a little bit more straightforward. What you're going to find is anytime you do have a fraction, rewrite it using that negative exponent. So instead of 1/3, we'd be like, hey, that's 3 to the -1 as an exponent. Okay. Well, then using our exponents rule, the power rule says I could just multiply these two things together. So that'll give me -x plus 2. All of a sudden, my base is 3 rather than 1/3. Okay. Now, this is only true if the numerator is 1 now. Keep that in mind. I'm operating because the numerator is 1.
So only if like if it's the top.
Yeah, so if it's 1/3, 1/5, 1 something, 1 over something, this works nicely. Okay. Now, keep in mind, as I mentioned, we can deal with other stuff. I could use 4/3. There's nothing wrong with 4/3. But that just means we have to take a little bit more tedious approach. So for our focus in this class, we're going to try to keep it with positive integers. Negatives bring a whole nother perspective that you'd have to deal with, a whole nother type of functions. Okay. Positive integers are nice focus. Any questions though with what I do with that J of X there? All right. So what if I give us something like this and I want us to go through the whole process of graphing? So as you see here, say, hey, given the exponential function, let's identify the domain, the transformations, the horizontal asymptotes, definitely something we want to identify, then graph it. And make sure you see here though, as you're writing that down, to highlight the fact that I made this 3 rather than 2. Make sure you see here to my graph, I'm counting by halves. Each tick mark is a half. Just kind of help with accuracy purposes. I'm not going to expect perfection on the test though. Does everyone understand that? It's like if I give you something with 1/9, I'm not like, did you put it at 1/9? Hopefully that's one thing that you're clear on. We do our best to get as close as possible. But there are some things that we can control, like stuff as you're going to see here, like the horizontal asymptote is definitely something we want to make sure we put where it belongs. Okay. The nice thing is we know we're going to have some integers somewhere when I do this. We're going to focus on those points for most of the times. Okay. With that said, though, what was the domain of that graph that we just did? What would you say the domain was? So we typically start all lower numbers, right? And we see restrictions. So was there anything issue that we ran into we couldn't use for the exponent? Could I do something like 2 to the pi, y'all? You think that would cause issues? You put in your calculator right now, it's going to give you a number that's not nice to work with, right? But 2 to the pi, we find we saw negatives work, we saw 0 work, we see positive numbers work, right? I pick on pi being irrational, right? 2 to the pi would just be some random thing. If you put in your calculator, you're going to get a decimal. It's going to be more than 8 because pi is 3.14. Okay. So make sure you see here that we can conclude then that the domain is all real numbers. So when you deal with these, make sure you see like, hey, my domain for these is going to be all real numbers. However, the range is not going to be all real numbers because we had the horizontal asymptote. So that'll be one thing we look at. I think I did that on the next slide. Yeah. With that said, though, the next step is identify my transformations. Now, remember for transformations, I just do a quick list, horizontal and vertical. I know polynomials, we couldn't really use transformations, so I did a little bit with quadratics as a review, but here's one area where we could definitely go back to transformations a little bit more than we did with polynomials. As you see here, though, what's the only thing that you see other than the 3? Right? That -4, let me do a different color. All right, is that a vertical or horizontal transformation? Is it with the exponent or outside of the exponent? Outside the exponent, right? Remember, our exponent is the main part. So this would be a vertical transformation where we say, hey, that means shift. And then we're going to go down 4. Okay. Now, the nice thing about this, right, from a transformation perspective is we had one thing that if we ever shift up or down, it'll be exactly what we said to do, right? Our horizontal asymptote was y equals 0. Multiplication does not affect 0. That's why we like the origin point, right? Anything times 0 is 0. So only a shift up or down will affect it. So what you're going to see here, anytime you have that shift up or down, go ahead and state your horizontal asymptote right after that. The nice thing again too about that is exactly what you saw, right? Whatever you have there, that is your horizontal asymptote. And we could start making our graph. So let me shrink this a little bit. So we go with where I'm getting that from. Now, what you're going to find here is the exponentials are not hard to graph. There's definitely a little bit more involved because we don't have the origin point like we used to. So what I always recommend students do is make sure first you get that horizontal asymptote in place. After that, once you get the horizontal asymptote, is to find where does the point that would have been at 0, 1 at now. Okay, well, we didn't have anything over here. There were no horizontal asymptotes. That means our focus is still going to be on this part of my graph. Okay, we're going to still focus on that part of the graph. There's no shift left or right. There isn't any other transformation. So I know that, hey, I have a point here. How do I know it's there? Well, I went from a horizontal asymptote and I went up 1. Okay, anything to the 0 power is 1. So from your horizontal asymptote, go up 1. Okay. With that said, we could check that out, right? Just to make sure that we get that straight. So 3 to the 0 minus 4 is 1 minus 4, which is -3. And that's right where I have that at. Okay. Any questions with that? Now, it didn't matter that it was base 3 at that moment, but paying attention to that base 3, your parent function will definitely be helpful here. That if you just kind of state it to yourself, remember, I could ask for the parent function on the test. That is definitely something we be comfortable with for any function, whether it's the final exam or if we had an exam for it, that's something you want to do. So make sure you see, that's why I would encourage you to take that practice exam forward just to kind of see some of the questions. that were on my test, but also make sure you understand we're not taking exam for our last assessment is going to be the final exam on that Wednesday that we just talked about to be in class. Okay. With that said here though, since I'm working with 3, right? Well, we need to think about 3 to the first and 3 squared, right? 3 to the first is 3, right? Now, I didn't put it at 3. I put it 3 above the horizontal asymptote, right? So what's 3 plus -4? Well, -1. 3 squared is what, y'all? 9, right? 9 plus -4 is 5. Okay. So what you're seeing here, though, is that this piece here is my 3 to the first. This piece here is my 3 squared. That's one thing I think helps with graphing exponential functions. As long as you get that horizontal asymptote first, I'm treating it like the x-axis almost right now. It is not the x-axis though, because it's at -4, but we can treat it similarly. Now, the fun part is if I have 3 and 9 there, what's going to be the fractions we use? One-ninth and 1/3, right? Are those going to be fun to graph by hand? No, right? So remember, understand, please see, I focus more over here first. This is my focus. And then I just do my best to be like, you know what? 1/3 is probably right there. 1/9, oops, not right there though. 1/3 is about right there. 1/9 is probably a lot closer to 0. Do my best to get as close as possible. But the key is remember, it's going to be flat and then my exponential growth. Now, as I mentioned here, it's going to seem flat, right? But remember, it's a horizontal asymptote. It never actually gets to that value, okay? Is there any question I could clear for somebody where I'm getting some of this wrong? As far as that graph. Would you say that looks a lot different than the one that we just did a second ago? I think what you'll find here is whenever you start changing the base to a larger number, you still get the same shape, but it's definitely stretched out more. And of course, that's because I'm using the counting by halves on my grid. So is there any questions with where I'm getting this stuff from though? All right, so make sure you see here though, like I said, I did my best to approximate these points, but I focused on those ones that worked out a little bit nicer. Okay. The one thing I would encourage you to remember is make sure you look for that kind of origin point that it's not an origin point now because I'm just using it for a point of reference though. Okay. So this was my horizontal asymptote at y equals -4. There was no shift left or right. So that's why I just kind of put a little, this has nothing to do with my graph. It was just me saying, hey, I'm focusing as if that was my origin. So from there, I went up 1, up 3, up 9, and graphed it out. Okay. What's the range then?
What's it?
Can-
-4 to.
All right. So can I go down forever? All right. The lowest we can go is the -4. Okay. What should I put on the -4 though? Can I?
No, yes, maybe so.
All right. Will we ever get to -4? No, right? This is from a mathematical perspective. Please keep that in mind, right? If I do 3 to the -100, it's still not 0. Now, technically speaking, if you put 3 to -100 in your calculator, what is it going to show you? Try it out. -100. 3, hit your exponent button and put -100. My guess is to put in scientific notation, right?
Yeah.
Where it puts like how many exponents on that 10. That's a lot of zeros, right? So at that point, we could just say it's what? It's pretty much 0, right? But understand, like, how many of you are doing, got to take biology or something? At that point, do we really need to deal with that? Well, it's all about the perspective, right? If we're talking about an atom, that means we probably need to zoom in and correct ourselves so that we actually do get that measurement, right? We do want to know that distance when we talk about molecules and stuff. And that's probably how big it is. It's that small, right? So that scientific notation is important, right? If we're talking about cutting off a piece of wood, at that point, it's like, don't even worry about it. Let's just move forward, right? So it's all about perspective on how we handle that. Mathematically, we just leave it in that nice, like, hey, it's 3 to negative 100. We'll deal with it if I ever have to. Okay. Any concerns though, where I'm getting this stuff from before we do another one? I think I have enough time here. I'm gonna go through this one a little bit more quicker though, because we only have about 10 minutes left. Okay, y'all. Now, make sure you see though, as you look at this one, I kept that base 3. So we're gonna have that parent function perspective of 3 to the x still. The reason we like that though, again, is like we're thinking 1, 3, 9, 1/3, 1/9. That's kind of that focus, that table that I set up earlier. Okay. If you need to build that table each time, right? This is a great table. Just write out if you get stuck. Don't feel like you have to do everything from memory. Write out the table. Put 3 to the x, fill out a table, and then use that to help you. Okay. As I move into this though, the transformations is definitely the thing I want to focus on here. So we have horizontal transformations, we have vertical transformations. Okay. As I deal with this though, is there anything in the exponent other than x?
Oh, yeah, that's
We have a +4, right? So we need to make sure to highlight that, hey, that's a shift, right? But what do we do horizontally? We do the opposite though, right? Is the opposite. That's the thing you have to remember is like, make sure you do the opposite with that. If you ever get stuck, remember quadratics, we talked about the vertex, right? So we had the x minus h squared plus k. That's a good way to help kind of remind yourself. If you ever forget it, go back to that vertex formula, the quadratic. Do the opposite for horizontal shifts. Vertically though, how many do we have? We have the 5. What did I highlight earlier though? We don't forget. That negative. Right now, is that a -3 or -3 to the power? That's the part that we have to be careful of, right? That's -3 to that power. Okay. So when you do that, make sure you understand that that negative is that reflection that we've dealt with in the past. And then the 5 will be our shift up 5. We good with where I'm getting all of those from? Any concerns? All right. Now, hopefully you took from what we just talked about. Remember your domain? We could have wrote that down right away. Hey, exponential domains all real numbers. I can move forward with that. Okay. The horizontal asymptote, what number do we take that from? Out of all that we saw here, which one's our horizontal asymptote? It's the vertical shift, right? So it's going to be it's not the negative, but the 5, right? It's going to be, hey, y equals 5. So whatever you see being added, subtracted to the exponent part, that's going to be it. Okay, so remember, that's definitely something we want to make sure locate, because we're going to go put that down right away. Now, once that's in place, what's going on with my range? Okay, because before we said go from the horizontal asymptote up, but once I put a reflection, am I going to be drawing my graph up or am I going to be drawing my graph down? Down. Right now, I kind of gave it away by putting my coordinate plane in a place where we could fit it, right? But understand here that we're going to say negative infinity up to whatever our horizontal asymptote is. Okay, because of the reflection. So instead of exponential growth, all of a sudden now we're going to have exponential decay. All right.
So the first one was exponential growth, now what's decay?
This will be decay. Now, I will say as we deal with this moving forward, there's going to be some situations that we do have to clarify some of this. So make sure I will do more examples to walk through that, okay? The ones that we've done, the first 2 graphs, those are exponential growth. This is one example of exponential decay. Now, why'd I put that mark there? Why am I putting this here, y'all?
Because it's the shift left.
Right, so that's my up 5, left 4. Is that a point on the graph? No, that has nothing to do with my graph. Right now, this does, right? The horizontal line I do there, I did a dotted line on purpose, right? Say, hey, that's my horizontal aspect. That's very important. That little green mark is just me saying that, hey, as I move forward to graph this, I'm gonna go down one right there. Because 3 to the 0 is 1. Why did I go down again though? What was the key?
To 0.
Right. But the reflection is why I went down. Okay. So from here though, make sure you see that I'm gonna go down 3. And then over here, we're gonna go down 9. Right, and that comes from the idea of 3 to the first, 3 squared, but remember, I'm starting at the horizontal aspect, and I'm just doing it downwards rather than going upwards. Now, you can plug in the numbers again. If you ever get stuck, make sure you remember that the whole point of this is to have a way to get to something, right? So this would be the one thing I remind you. If you get stuck, use your transformations to help you. The key here is that 4 tells you to start at -4. So you can plug -4 in and see what it works out. But the nice thing about it, what's -4 plus 4? That's why we want to start there, right? Let's get these nice things. From there, just plug in -5, -6, -3, -2. Fill out the table and you have a graph. You do not have to feel like this is all something that you just got to pull out of a hat and remember. Use the information to help you locate stuff, right? The 5 is very important because that told me, hey, put that dotted line at y = 5. That's my horizontal axis, so very important. The negative, I'm going downwards. That's another important part, right? The +4, well, hey, I definitely need to know it got shifted to left 4. I would say that once you get this in place here, if you're plugging in points, it could actually help you with the rest, okay? It can help you with the rest. Now, make sure you see here, though, as your graph is concerned, it's going to look something like this, where that exponential growth is going downwards now, which is why I call it exponential decay. Any questions or concerns here? So we feel okay with that? I will say this as a graph itself, it's not, one of the more involved graphs. Like rationals, we definitely had a little bit more going on as far as doing graphs, right? But make sure we focus on stuff that can help us do the graph quickly. That's the key here. What can I do to help me be more confident, get done quickly? There's almost always one of these on the final. So it's definitely something you want to be comfortable with, right? This, the quadratics, those things definitely expect to see on the final. All right, now as you pack up, know that tomorrow we got to go in a little bit further. So we're going to talk about like intercepts. But as we talk about this, there's also going to, that's not what I wanted to swipe to, sorry. Applications, right? So just make sure you get ready that we will expand to a couple other areas, but that's going to be our focus. Just, hey, what's some new functions, okay? Have a good day though, and I will see you tomorrow.